Greetings and welcome, friends. Mr. Waddy here, showing you section 1.2 from Big Ideas Common Core Algebra 1 textbook. Today we're solving multi-step equations, multi-steps. So far we've been solving equations using inverse operations. We've been undoing the thing that happens to the variable to get the variable by itself, or as the mathematicians call it, to isolate the variable. Okay, and now in this case, instead of just a single operation having happened to the variable, like x plus 2 equals 7, or 3x equals 4, or something like that, we're going to have multiple operations having occurred to the variable, and we're going to have to simplify first. So the first problems we're going to do actually don't have necessarily multiple operations per se, but just require some amount of simplification first. So here we go. I'm going to throw this example at us. Let's see. That looks pretty good. I like it. So here's two examples for us, and I'm asking us to solve. Now, me and my friends here in math class, we were just practicing Khan Academy's combining like terms activities. Khan, represent. Me and Sal go way back. He sends me emails like all the time. Actually, Khan, you're kind of overdoing it a little bit, but that's fine. So here we go. The first thing I need to do to solve this, I don't know which x to get by itself yet. So I'm going to combine like terms. So here, like terms are 3x and 2x like terms. Yes, no, maybe so? Yes, yes. They have the same variable, and they have the same invisible exponent of 1, and then each of them have a coefficient. In this case, the 3x's coefficient is the 3, the 2x's coefficient is the 2. So those are like terms, so the first thing I'm going to do is simplify. I'm going to combine like terms. Now here's an equal sign. If there was some other x over here, which we'll see in a couple days, this I couldn't combine with these because it's on the opposite side of the railroad tracks right now. We'll figure out how to deal with that later. But 3x's plus 2x's is how many x's, friends? 5 x's. I like it. 5 x's. So 5x equals 25. So now that I've simplified the equation, now I'm going to use my inverse operations. So what is currently happening to my x? What's happening? X is being what? X is currently, I want to get x alone. It is currently being multiplied by 5. So what is the inverse? What is the opposite, so to speak? Yeah, the opposite of multiplication is division. So the undoing of multiplying by 5 would be to divide by 5. And of course, I have to do it on both sides of the equation so that my equal sign will still be true. And notice when I use inverse operations, you don't have to write this part, but 5 divided by 5, that would cancel out, and I would in fact get the x by itself or isolated, which is what I want. So you should always kind of like just think about like, is my move actually going to kill the thing in front of the x or the operation that's happening to the x, right? I want to make sure that it's actually working. So here I would have x equals 25 divided by 5 is 5. So I get x equals 5 right there. And if I did a check, right, but I actually care not at all about your ability to have guessed that. I'm interested in, do we know the process? And if I did a check, I'll just do it for this one, I would have to plug 5 in for every location I see the x. So let's see, for the check, I have 3 times 5 plus 2 times 5. Is that equal to 25 is the question. Let's see, where's my little scroll bar hiding? Right there. 3 times 5 is 15. 2 times 5 is 10. Is 10 plus 15 25? Oh, in fact, it is. So 25 equals 25. It appears as though we found the correct solution. All right, not bad. Let's take a look over here. So step 1, simplify. Are there any things that I can combine, any like terms on left or right-hand side? Like terms. Yeah, so I've got negative 4x's plus 1x, which actually it's not a bad idea. I just want to make sure you guys realize that there is an invisible 1 coefficient in front of that x. So when I combine like terms, negative 4x plus 1x, ooh, man, I got to add the negative 4 and the 1. The signs are different, so I subtract them. 4 minus 1 is 3. And I take the sign of the more influential. Who's more influential, negative 4 or positive 1? Which has the bigger absolute value is the way mathematicians said it. Whose sign am I taking, the negative or the plus? The negative, because 4 is further from 0 than 1 is from 0. So this is negative 3, and these are measuring x's. Right? So negative 3x's. Negative 4x plus 1x is negative 3x's. Equals, here, that's a negative 12. I know that minus sign is kind of like hanging out awful close with that equal sign. And so now that I have simplified, let's solve. What is currently happening to x? X is being subtracted by 3, is that right? No. No. No, the operation at play, my friends, is multiplication. All right, so don't see that minus sign and then be like, oh, I've just got to add 3 to both sides. Incorrectamundo. We've got to divide. The inverse operation of multiplication is division. I'm going to divide both sides by the same thing. And multiplying by negative 3, the inverse would be to divide by negative 3. Okay? So here I've got negative 3 divided by negative 3. The 3's would cancel. The minus signs cancel. I do, in fact, get x by itself. Let's see, a negative divided by a negative is positive, and 12 divided by 3 is quattro. All right? So that's how we can use simplification before we solve a problem. Right? It's a great thing to do. Good idea. We want to do it. Hip, hip, hooray. So let's actually get into what I would truly call, this just required simplification, but here's what I would truly call a kind of multi-step example here. A 2-step equation, 2 steps. So here, right, I've taught you how to punch, I've taught you how to kick. We're going to have to both punch and kick to solve this problem. Not literally, don't harm anyone, please. So solve 2.5x minus 13 equals 2. Now, think about this in terms of PEMDAS. Okay? From x's perspective, all right, step 1, what happens to x? Is it being subtracted by 13 or is it being multiplied by 2.5 first? Right? It's being multiplied. Multiplication happens before subtraction for PEMDAS, right? So step 1 for x, x wakes up in the morning, steps out of bed, it's being multiplied by 2.5. Okay? Step 2, what happens to x? So after it's being multiplied, then what happened? It was being subtracted by 13. We'll get there. We'll get there. We're not on the solving yet. I'm trying to break this down for us. So it's being subtracted by 13. So those are the 2 things that are happening to x according to PEMDAS. Now we've been solving equations by undoing the thing that happens to the variable, right? So if the variable was being subtracted by something, I'd added something to both sides. If the variable was being divided by something, I multiplied both sides by that. So I've been undoing what's been occurring to the x. However, in this case, the most efficient way to deal with this is not only to undo the operations, but to do them in the reverse order. Imagine like you're diffusing a bomb. You've got to kind of like do it in the reverse order. I want to get x by itself, but I can't touch this 2.5 yet. All right, I've got to do it in the reverse order that it was assembled in, so to speak. So when I'm solving a multi-step equation, instead of PEMDAS, I'm going to SADMAP. Or actually, I heard one of my colleagues refer to it because multiplication division can be done from left to right. He actually referred to this as Sam Depp, Johnny Depp's brother, which I thought was kind of amusing. So I'm going to just, give him that little shout out. Mr. Kinlock, bam, represent. So Sam Depp. So I need to undo this in the reverse order. So step one for SAD mapping, if I want to deal with this, step one, I have to do this in the reverse order. So how do I deal with subtracting 13? What's the inverse? What's the opposite of subtracting 13? I'm going to add 13. And then what's the opposite of multiplying by 2.5? Yeah, I'm going to divide by 2.5. So notice when I'm solving this, I'm not only doing the opposite or inverse operation, subtraction became addition and multiplication became division, I'm doing it in the reverse order, SAD mapping it. Okay, so in order to solve this, the first thing I deal with is subtraction. And we already said the opposite of subtracting 13 is adding 13, so add 13 to both sides. And I can only do one step at a time, so this is where I'm at, step one. So let's see, 2.5x is still 2.5x. Oh, I actually swapped colors here for my normal palette. Tell you what, I'm going to write this in the orange, plus 13, plus 13. Here we go. And so I'll have 2.5x, that's unchanged. What's negative 13 plus 13? That's just 0, right? That just disappeared. We undid it. Equal sign, when we're doing our work, we work vertically. We keep our equal sign in a column, right? So it's nice and consistent. We show our work on one step and the results on the next row. What's 2 plus 13? 15, right? And so remember, I'm adding 13, but I'm also adding it to both sides of the equation because I want to make sure this is still equal at the end of the day. I had to add the same amount to both sides of the balance beam scale thing, right? Right. So notice, what do I have now? Now I have a single step equation. These are the kind that you guys were solving last night. And we already talked about what we have to do. So I added 13 to both sides. Now I'm dividing both sides by 2.5. Okay, so I'm just doing the inverse operation. Here we go. So x is being multiplied by 2.5, so I'm going to divide both sides by 2.5. Represent. So let's see. So the 2.5s cancel out. That would make sense. So I would get x by itself, equal sign in a column, carry it down, right? And 15 divided by 2.5. Man, we could do some long division, but this is the way I'm thinking about it. 2.5 is half of 5, right? You guys agree? How many times does 5 fit into 15? 3 times. So 2.5 has to fit into 15 twice as much. All right? If you didn't get that, that's fine, right? You can practice some long div. You could do, right, 2.5 into 15 or something like that, and you could do all that crazy stuff. Maybe you would shift the decimals first and write that as 150 divided by 25. That's fine. But I'm not going to take a lot of time on that. We're talking about solving today. So I get x equals 6. X equals 6. Final answer. Now, question for those of you who are answer guessers. If you had just looked at that, would you have been like, 2.5 times what minus 13 equals 2? Oh yeah, 6. Like, probably not, right? I would question your ability to be able to just look at a multi-step problem and be able to guess the value of x. Last night, yeah, guessing is easy, right? You could have just been like, yeah, that makes sense. In this case, not so much. So the more complicated the problem becomes, our guessing strategy becomes less efficient, and our solving strategy becomes the conquering tactic. All right? So it did say to check our solution. I guess I can check our solution. So when I do a check, if x is equal to 6, everywhere there's an x, I'm going to plug a 6. Let's see, ck, check. So 2.5 times 6 minus 13, is that equal to 2? 2.5 times 6, let's see, 6 times 2 is 12, right? 6 times 5, or 0.5, would be 3. 12 and 3 is 15. Minus 13 equals 2. That is 2 equals 2, friends. 2 equals 2. Cha-ching. It checked out. I got the right answer, to my knowledge. I mean, unless I made some mistake. And remember, for the check, I'm not doing algebra. I'm not adding 13 to both sides. I'm not doing all that. I'm doing order of operations when I do this setup. Let's see, where did I lost my thing here. Let's look at this next problem. All right. Actually, I'm gonna jump right to this. I like this. I like it a lot. Here, let's just practice a bunch of these today. Here we go. All right. So there's multiple things happening to the variable. We should always simplify when possible. Okay. But we have to think of doing it in the reverse order when we're solving. We're SAD mapping. So for problem 1, do I want to deal with this multiplication or addition first? Which would SAD map tell me to do? Addition. So to deal with the addition, what's the opposite of adding 3? So I'm going to subtract 3 from both sides. Theoretically, you can try dividing both sides by -2, but it'll create a bunch of fractions. And in general, students are not fans of fractions. Let's see, 9 minus 3. Signs are different, so I subtract them, I get 6. Take the sign of the more influential, which is 9. So yeah, positive 6. All right. Yeah, and let's see. So n is now being multiplied by -2. The inverse of multiplication is dividing. And so I want to divide by what? Yeah, better yet, -2. We'll get rid of that minus sign at the same time, right? So negative divided by negative is positive. 2 divided by 2 is 1, and I just get regular 1n. That's what I wanted. Bring my equal signs down. So notice, I would recommend you working with your 2 different colored writing utensils tonight. 6 divided by -2, 1 minus sign, so it's still negative. 6 divided by 2 is 3. Let's see, I might not have time to check our solutions in this moment right now. Let's take a look at this one, problem 2. 2 things are happening to C. It's being multiplied by 1/2 and subtracted by 11. So which operation do I have to get rid of first, according to SAD map? Multiplication or subtraction? Subtraction, right? So I'm doing this in the reverse order with the reverse operation. So the opposite of subtracting 11, plus 11. Right? Okay. So, man, -21 plus 11. Signs are different. So I subtract the numbers. 21 minus 11 would be 10. And I'm keeping the sign of who? 21, because 21 was more influential than 11, so it's -10. These 11s canceled out, so I just have 1/2 C over here. And now we actually have a few options. I could think of this as multiplying by 1/2. So the inverse operation would be dividing by 1/2. Ah, man, guys, dividing by a fraction, that's terrifying. Another way of describing dividing by a fraction is to multiply by the reciprocal. I don't know if you guys remember that concept from back in the day. So multiplying by 2 over 1 is the same as dividing by 1/2. Yeah, we'll do it this way. Don't let the fractions scare us. Let's see, 2 over 1, that's just 2. 2 times -10 is -20. And these 2's cancel out, those 1's, quote unquote, cancel out. I get C by itself. Notice my equal signs kind of staying in a column. And I get -20 equals C, but let's just flip that around. C equals -20 sounds much better. We don't have to have our solutions in Yoda speak. -20 equals C, right? But that doesn't make sense. We'll just say C equals -20. Way better. Okay, so the way we did this is SAD mapping. Right? SAD map. Now this next question, they done combined some of our concepts here. Combined, actually, quite literally. Before I start SAD mapping, I want to simplify. Are there any like terms that I can combine first? Because they both have x's, right? So let's see, so I've got -2x and -10x are my like terms. So we'll simplify first. I'm not even thinking about inverse operations yet. How many x's do I have? -2 of them and -10 of them is negative what of them? 12. It's becoming more negative. Okay. Now I've simplified. There was nothing to simplify over here. 12 didn't have any like terms on the same side of the equal sign, right? So don't try to combine these guys. They're on opposite sides of the equal sign. Now it's like one of these problems. Now I'm ready to solve using SADMAP. What do I deal with first, multiply or add? Add. So what's the opposite of adding 12? Subtract 12. Guys, we're getting this. I like it. I like it. And so I'm going to have -12x, equal sign, bring it down, bring it around town. 18 minus 12, it's going to be 6, and the more influential number was 18, so it's +6. Okay, now what operation is happening here? Is it subtraction or? Well, right, yeah, multiplication is happening, so you guys are going to divide. You're right. Right, so I don't want to try adding 12. What's happening here is multiplication by a negative. So divide by -12. Ooh, interesting. We haven't done one of these yet. The minus signs cancel out. The 12s cancel out. I get x equals, is this going to be positive or negative? Negative. And now 6 over 12. Ooh, I don't know if you guys remember how to reduce fractions. 6 and 12. What's a number that goes into both 6 and 12? 6, yeah, 6 goes into 6 once and into 12 how many times? Twice. So I can reduce that fraction to 1/2. If the fraction part scares you, you could go to, just search Khan Academy for simplifying fractions, and that'll help you out. Now, if I was to do a check, which I'm not going to take the time to do today, for this problem, in my check, I have to plug this in for everywhere I saw an x. Right? For this one, I would have had to plug it in everywhere I saw a C, which was only one where, right? So that's how I would do my checks, and they would work out. But this is the big idea, is not only do we do the opposite operation, but we do it in the opposite order. You're diffusing a bomb here. You're trying to get the n by itself, the variable by itself in each of those cases. All right, well, thank you for watching, Internet friends. Have a great day.